Today we're going to talk about mountain building. All right, so deformation or deformation is the process by which the shape of a rock changes because of stress. So there are three main ways it changes. Okay, the first way is by compression. So this is when rocks are squeezed together. They are compressed. Compression is a great way to remember convergent. They both start with C. So compression is pushing something together, making something that's big fit in a small space. Great example of compression would be a stress ball. Okay. Tension is the second type of deformation, and it's where rocks are stretched. And so it's going to be like a rubber band. And the third type is shearing, and this is where rocks are pushed in parallel but opposite directions, okay? Kind of like subways or trains. All right, folding. Folding is the bending of rock layers because of stress. So there are a couple of things we need to know. We need to know anticline and syncline. So anticline bends up. I always tell students to draw an A. The A represents the arch, which is the movement up right here. Okay? It's where the youngest layers are found on the outside of the fold. Because remember, older layers are on the bottom. The syncline bends down. It's the oldest layers are on the outside of the fold instead of the youngest layers. Great way to remember this, syncline is a smile. Okay, this would be your mouth, and then we just add our eyes. Okay? All right, let's talk about faulting. When we talk about faults, we're talking about cracks that form when large blocks of rock break and they move past or slide past one another. And then we have the fault plane, which is where this place is going to occur. It's the location where the two faults meet. So a lot of time it's drawn like this. And this line right here would be the fault plane. Okay? So there are two terms and two parts of a fault that you must know. The first term is hanging wall. The second term is footwall. When we're talking about a hanging wall, we're talking about a wall that basically allows a swing or a rope to hang from it. So hang above. This right here is the hanging wall because you can see she is hanging on this rope right here. The second wall is a footwall. It's called a footwall because it has no edge to hang from. Basically, you could walk up it, just like this person's going to do right here. So the hanging wall allows you to hang from it like a swing. The footwall allows you to move up it on your feet. All right, so there are three faults. This is the first fault, okay? This is a normal fault. In a normal fault, the hanging wall, which is here, this is the hanging wall, is going to move down the footwall. See how the fault slides down? And it's formed from tension. Again, this is going to be like rubber bands. When it pulls apart, the fault is going to move. And this is formed at divergent boundaries. Normal faults are divergent boundaries. You can see that as here, our arrows are pulling it apart. This is an example. And it's the Basin and Range area in the southern United States. You can clearly see in the picture that at one point these were beautiful and that they have slid down and now created angles. The second type of fault is a reverse fault. And this is where the hanging wall is going to move up the footwall. So it's going to slide up and over because of compression. It's being pushed together, okay? This is why we have a lot of really pretty tall mountains. The San Gabriel Mountains are an example. This is them right here. And this is formed at convergent boundaries. Reverse faults are convergent boundaries. Both of those, normal and reverse, have the footwall and the hanging wall, and they move in relation to one another. The third type of fault is a strike-slip fault, and it does not have that. This is going to be formed at transform boundaries, and there is no hanging wall and no footwall, okay? It's because it's just side to side. Great way to remember it, strike, slip equals side to side motion or shearing. And big one, this one causes earthquakes. So this right here is the San Andreas Fault. This is a real picture. On this side we have the North American plate. On this side we have the Pacific plate. They move opposite of each other, and anytime there's a motion, there is an earthquake. So you can clearly see one goes this way, one goes this way, and this is the result. They do not line up. All right, so let's talk about mountains. Mountains are often formed when we have folds created. So the first type of mountain is a folded mountain formed from continental collisions through compression. Continental is going to again be at convergent boundaries. So the example I'm going to give is the Appalachian Mountains. So this is where they are in the United States. They do run through North Georgia. And basically what happened is when the North American plate collided with the Eurasian plate and the African plate, this is what was left over. It was a push up of mountains. The Appalachian Mountain Range is actually very, very old. So we have our two plates coming together. We know when mountains are formed, they come together and they push up because that's the only thing two continental plates can do. The result is the mountain range that's created here. This is the Appalachian Mountains. The second type of mountain is a fault block mountain, and tension is going to cause these large blocks of crust to slide down. Okay, the Teton Mountains and the Sierra Nevada Mountains are examples of these. One thing to notice, a lot of times you'll see this really jagged peak-like motion across the top, and that's because originally they would have been all lined up like you see here, and over time the faults have caused them to slide down, and so it just creates this jagged irregular motion across the top. Okay, so fault block mountains form from tension, and tension is from divergent boundaries, okay, or normal faults. All right, the next type of mountain is a volcanic mountain. I'm pretty sure you're familiar with that. A volcanic mountain is where magma rises to the surface and it cools to form a volcano. When this happens, you know you have your magma chamber here underneath the Earth's surface, which causes the magma to rise up. When it gets full, basically it creates an eruption or an explosion. Most volcanic mountains are located on the Ring of Fire around the Pacific Ocean. Great example is Mount St. Helens. This is in Washington State, part of the Cascade Mountain Range, and it blew its top in May of 1980. So this is after May of 1980, this picture right here. Originally it did have a giant peak, and that's the part that was basically blown off. The whole north face was when the volcanic mountain blew. So volcanic mountain is just another word of saying essentially it's a volcano. The difference between these and the fault block mountains and the other mountains as well, this one has this magma chamber here underneath the surface that will allow it to eventually erupt, whereas the other ones do not. They do not have magma underneath the surface.